Are you using MATLAB for data processing and do you want to simulate power electronic systems quickly? Well, now there's an interface between MATLAB and PLECS Standalone. PLECS Standalone not only offers high simulation speed and a simple user interface, but it also allows for parallel simulations. And this is important, for example, if you want to explore different operating conditions of your system in a quick manner. Now I'll show you how this is done in 3 simple steps. The first step is to install the JSON RPC client. The second step is to set up the PLECS site, and then in the third step we write the simulation script that calls the PLECS Standalone simulation. You can find all the resources for this short tutorial in the description of this video. So let's get started. I open our GitHub page and here I download the JSON RPC client. I download the zip file. In my case, this is downloaded into the folder called example, where I extract the zip file. So let's look into the folder, and there is the JSON RPC.m file, which implements the client. There is a license and a README file. So let's go to the second step, which is setting up the PLECS site, where we create a new PLECS model using file new model. And let's do something very simple here. We can just add a voltage source as an example, a resistor, and an ammeter to measure the current. I use the auto connect feature to quickly connect those components together. And let's add a scope to display the simulation results. Now let's go to the simulation parameters and limit our simulation time to 20 milliseconds. And now we can perform an offline simulation. So let's do simulation start. This is all happening now in PLECS Standalone, and we find, as expected, our sine wave with 1 amp of peak amplitude. All right. So there are a few more things we should do when we want to interface to MATLAB. For example, we want to be able to send back data to MATLAB and to post-process it there, for example. So this can be done using a signal out port. And let's increase the size of the circuit a little bit. And so all the data that enters the signal out port is then transferred back to MATLAB. So this is the data sent back to MATLAB. Now what we can also do and should do is we want to later change variables in our system. And here, for example, the resistance is configured or hard-coded as 1 ohm, but we could just use a variable R that we can later overwrite. Now we should initialize this variable in the init commands of the model. So here I say R equals to 1 ohm, and later we can overwrite this variable. We also have to enable the RPC interface in the PLECS preferences. So I go to the PLECS preferences and check that the RPC interface is enabled, and we leave the default port 1080, and yeah, this is basically the default one configured when you open PLECS. So let's click OK, and let's save the model in the same folder as we have our JSON RPC.m file. Now, this file could also be placed or be added to your MATLAB path, and then you can use it globally across your system. Let's call the model circuit and save it. So now let's go to the third step, which is basically writing the script in MATLAB. So here I have the folder MATLAB JSON RPC main. So if I enter the folder, you can find the JSON RPC.m file and then the circuit.plex file that we have just created. So let's edit a new file called circuit script. And here we are going to implement basically the script that calls the PLECS simulation. So let's put this side by side. And in the first line of code, I'm going to create a proxy object that calls the PLECS standalone simulation over the JSON RPC interface. So it's called JSON RPC, and then the argument is the URL of the server. And in our case, this is running all on localhost, and we are listening on port 1080. So we write HTTP://, and then localhost, and then specifying the port number. In the second line of code, we set up a simulation struct. And this contains all the variables that we want to transfer over to PLECS standalone. So we create a struct, and this actually needs to contain a field called model vars. And in here, we can now specify our resistance R. And now we set it to, for example, 2 ohms instead of 1 ohm that we have in the model. In the third line of code, we call the PLECS standalone simulation using this proxy object. So I write proxy.plex.simulate. And this simulate method has 2 arguments. First, it's the model name, so it's called circuit. And second, there is the simulation struct. So the simulation also has return values. So we said that these are the values that are sent back to MATLAB. So we can write results is equal to this call of the simulation. Okay. So let's save it and run the script. And when we check back in the console, we see that 2 fields are returned, one's time and values. We can use these now to plot or post-process the data. So let's, for example, plot the simulation results. So I say plot, and then first is results.time, and then it's results.values. So if I run the simulation again, now you see we get 1 sine wave back with a peak amplitude of 0.5 amp, as we expected for 2 ohms of resistance. So this is a very simple example on how to interface MATLAB with PLECS standalone. If you want to find or do a bit more detailed or complex example, then please check our website where we have a tutorial, and this also explains on how to do parallel simulations, for example. On our website, you can also find the download for PLECS standalone, and you can also request a trial license so that you can start with this setup today. Thanks a lot for watching, and see you in the next video. Thanks.